Have you ever found yourself wondering what truly drives someone to relentlessly pursue these, well, seemingly impossible goals?
You mean things like building the internet basically from scratch,
Yeah.
or, rocketing humanity to Mars?
Exactly. Today, we're diving deep into this incredibly rich set of insights from a recent, very candid interview with a figure who's pretty much synonymous with these kinds of ambitious ventures.
Yeah, that's right. And this material, it's straight from the source, which is rare. It gives us a real look into his, early struggles, his core philosophies, and his huge vision for the future.
Especially in AI, space, and, well, humanity itself.
Mm.
Our goal in this deep dive is really to pull out the most important nuggets of knowledge, the key insights from this conversation.
Kind of provide you with a shortcut, maybe, to understanding the mindset behind some of these really transformative companies and ideas.
Precisely. We're aiming for those moments where something just clicks, you know? And maybe you see things a little differently.
Yeah, those aha moments.
Right. And to really get that mindset, I think we need to start by looking back. Way back, actually, to a pivotal moment in 1995.
Okay.
So picture this. Our subject faced a pretty fundamental choice. Option 1, pursue a PhD at Stanford. Material science, focusing on ultracapacitors for electric vehicles, basically trying to solve the range problem for EVs back then.
Which was a huge problem, still is to some extent.
Or option 2, jump into this brand new thing called the internet, which, as he recounted, most people had never heard of at the time.
Wow, talk about a fork in the road. It's hard to even imagine the internet being that unknown now.
Isn't it? And what's really striking is how low the expectations were. Like, zero expectation of success, almost.
He actually talked about that. He went to his professor, Bill Nix, in the material science department, and asked if he could maybe defer for a quarter.
Thinking he'd be back soon.
Exactly. He said, and this is his own quote, "This will probably fail, and then I'll need to come back to college." He was planning for failure.
And the professor's response?
Even better. Professor Nix apparently said, "This is probably the last conversation we'll have."
Ouch. Talk about a vote of confidence.
You could just feel the skepticism, right? Like, sure, kid, go play with your internet thing.
Totally. And despite that, that clear expectation of failure, he just dove in head first.
And the stories from building that first company, Zip2, they're legendary.
Oh, absolutely.
Yeah.
He personally wrote what he called the first, or close to the first, maps directions, internet, white pages, and yellow pages on the internet, all by himself.
And the tech setup.
Yeah.
Get this?
Yeah.
He didn't even use a web server.
No server. How does that even work?
He just read the port directly, said he literally couldn't afford a T1 line, which was the standard connection back then. The resourcefulness was just extreme.
It really was. And the office situation, that paints a picture too.
Oh, yeah. Famously drilling a hole through the floor to run a LAN cable down to an ISP on the floor below them.
Because they couldn't afford their own connection, right?
Right. And they couldn't afford a place to live either, so they just lived in the office.
For $500 a month, showering at the YMCA.
I mean, showering at the YMCA, that's a level of bootstrapping, of just pure grit. That's hard to imagine today, isn't it?
It really speaks to the conviction, the sheer will involved. But, even with all that effort, all that groundbreaking tech they built at Zip2, there was a major catch.
The investors.
Exactly. He said Zip2, despite building a lot of really good software technology, was, quote, somewhat captured by the legacy media companies.
Names like Knight Ridder, the New York Times, they were investors. They were on the board.
And they kept pushing for decisions that, in his words, made no sense. They didn't get the internet, basically.
That's a really common story, unfortunately, especially when you're trying to disrupt established players. They often just don't see the vision.
He wanted to go direct to consumer, which was way ahead of its time. But he was totally blocked by these legacy companies.
Yeah, it really shows how important investor alignment is right from the start. They essentially clipped his wings, forced the company down a path that wasn't maybe the best one long term.
So eventually, Zip2 gets sold. $300 million. His share was around $20 million.
Which back then, I mean, that was a lot of money. Life-changing money.
Definitely. But he made this interesting comparison to today's market. He said that $20 million, now that's like the minimum impulse bet for an AI startup, which might raise $1 billion just like that.
He definitely noticed the difference. He called today's AI valuations eye-watering and talked about the intense hype level. Said there's a herd of unicorns now.
It's a different world, but what's really surprising, going back to Zip2, is that his initial goal wasn't even to start a company at all.
Right. He just wanted to, quote, be part of building the internet. That was it.
And he actually tried to get a job at Netscape, which was the internet company back then.
Oh.
Sent his resume.
Crickets. No response.
And then he actually went and just like hung out in their lobby, hoping to bump into someone.
Yeah, but he admitted he was too shy to talk to anyone. Can you picture that?
It's hard to reconcile with his image now, isn't it? So basically, when he couldn't get a job building the internet, he started a company to do it instead. Almost like a plan B.
A very, very productive plan B, it turns out.
Okay, so he gets this $20 million check from selling Zip2. What does he do? Take a vacation. Buy a fancy car.
Nope. He made this incredibly audacious decision. He invested almost all of it, basically everything, into his next venture, X.com.
Which eventually merged with Confinity to become PayPal.
Exactly.
Yeah.
He described it as keeping the chips on the table, rolling the dice again, but bigger this time.
And the motivation.
Pretty clear, based on the Zip2 experience. He said he felt their wings clipped at Zip2, and this time he was determined to go direct to consumer. No intermediaries, no legacy board members telling him no.
And that decision, X.com and then PayPal, it had huge ripple effects, didn't it?
All massive. It led to what people now call the PayPal diaspora, that group of early employees and founders.
Right.
They went on to create, as he put it, more companies than probably anything in the 21st century.
It really was a catalyst for a whole generation of tech entrepreneurs.
Absolutely critical moment.
So after PayPal gets bought by eBay, the story takes another really unexpected turn. His focus shifts dramatically.
To Mars.
To Mars. He literally went to NASA's website looking for their plan to send people to Mars.
And found.
Nothing concrete. He said there was no date and no real plan. Just sort of vague ideas.
Which is kind of shocking when you think about it.
Yeah.
NASA and no plan for Mars.
Right. So this sparked an idea. Initially, it was philanthropic, a mission called Life to Mars.
What was the content?
Basically, send a tiny greenhouse to Mars. Inside, dehydrated nutrient gel. The idea was to rehydrate it on landing and grow plants. Get this money shot, as he called it, of green plants on the red background. Inspire people.
That's quite a vision. Starting small, aiming for inspiration.
But trying to figure out how to get this greenhouse to Mars led him down another rabbit hole.
The rockets.
Mm-hmm.
Or lack thereof.
Exactly. It even led him to Russia in 2001, 2002. Trying to, and this sounds insane, buy ICBMs, intercontinental ballistic missiles.
From the Russian military.
And
Seriously.
Seriously. He described the negotiation process as just bizarre. They'd meet, have drinks, talk price, and the price just kept going up with each meeting.
Okay, that does sound pretty weird. Not exactly a standard procurement process.
Not at all. And through that whole adventure, he realized something crucial. The problem wasn't a lack of will to go to Mars. It was the sheer prohibitive cost. Rockets were just too expensive.
So if you can't buy them cheap.
You build them yourself. And that's when he decided to start SpaceX.
Knowing full well how hard it would be.
Oh, yeah. He estimated himself a less than 10% chance of being successful. Maybe even just 1%.
Wow, those are terrible odds. Why even try?
His logic, a small chance of success is better than no chance. He felt someone had to do it.
And the recruiting pitch reflected that pessimism, didn't it?
Brutally honest. He apparently told people, we're probably going to die, but a small chance we might not die.
That's one way to attract talent. Who signed up for that?
Apparently enough people who believed in the mission, but he also ended up becoming the chief engineer himself.
Why? Couldn't find someone.
He said none of the good sort of chief engineers would join. They probably thought he was crazy. An internet guy building rockets.
Which, to be fair, it does sound a bit crazy on the surface.
Well, right. And the early days were just harrowing. The first 3 SpaceX launches all failed. Blew up.
3 failures in a row. Most companies would fold after 1, maybe 2.
The pressure on the 4th launch must have been unbelievable. He said it absolutely had to work. There was, quote, no money left.
It was literally do or die for the company. He called it the curtains moment. Everything was riding on that single flight.
And this was all happening around 2008, which he described as just a rough year. An understatement, I think.
Because it wasn't just SpaceX, was it?
No. The 3rd SpaceX launch failed that summer. And over at his other company, Tesla, their crucial financing round had also fallen through. Both companies were on the brink of collapse simultaneously.
And the public perception.
Terrible. He was being ridiculed everywhere. The internet guy playing rocket scientist and car manufacturer. He even acknowledged himself, yeah, it does sound pretty absurd.
You can just imagine the stress, the weight of 2 potentially world-changing companies resting on your shoulders, and everyone's calling you a fool.
It must have tested his resolve to the absolute limit. But then, the turnaround. like something out of a movie.
The fourth Falcon launch.
It worked perfectly. August 2008. SpaceX was still alive.
Huge relief. But they still needed money, contracts.
And then came the phone call. Just before Christmas, December 22nd, 2008. It was NASA.
Offering the commercial resupply services contract.
Exactly. A massive contract to resupply the International Space Station. He apparently just blurted out, "I love you guys," on the call. He said later it was a true company saver.
Wow. The timing. Unbelievable.
And it gets better. 2 days later, Christmas Eve 2008, Tesla's Lifeline arrived.
They closed that financing round.
They closed it at 6 p.m. on December 24th. He said it was the last hour of the last day that it was possible.
Literally down to the wire.
If they hadn't closed it then, they would have bounced payroll 2 days after Christmas. Both companies saved within days of each other. Incredible.
Talk about a Christmas miracle. After navigating that kind of near-death experience for both companies, it really feels like he forged a distinct philosophy, a blueprint for how he builds things.
Yeah, absolutely. And it seems to start with this idea of what he calls true work.
He puts it very simply. He advises people to try to be as useful as possible to fellow human beings. That's the core goal.
And he defines true work by its, area under the curve of total utility.
Yeah, it sounds a bit technical, but the idea is simple. How useful is something? And how many people does it help? The bigger that combined value, the truer the work.
It leads to this counterintuitive mantra he has: don't aspire to glory, aspire to work.
Right. Focus on the contribution, the usefulness, not the recognition or the ego boost, which ties into his next point, doesn't it?
About ego being a major failure mode.
Exactly. He talks about the ego to ability ratio.
Yeah.
If your ego is bigger than your actual ability, he says that ratio is greater than 1.
And that's bad because
Because it breaks the feedback loop to reality. It stops you from learning and improving. He even uses an AI term for it, the RL loop, reinforcement learning loop. If your ego's too big, you ignore the feedback, the reality checks.
So the key is to keep that ratio below 1.
Right. By internalizing responsibility and minimizing ego. And being willing to do whatever the task is, no matter whether it's grand or humble. Pitching in where needed.
You know, that actually helps explain something. He mentioned his preference for certain words.
Like engineer instead of researcher.
Yeah, and company instead of lab. He said he aims for the simplest, most straightforward, ideally lowest ego terms.
It keeps the focus on the practical, the tangible, the feedback from the real world. Less room for abstraction or, well, ego.
Okay, so minimizing ego, focusing on usefulness. This philosophy seems directly connected to what he calls his superpower, which is first principles thinking.
Ah, yes, first principles. It's fundamental to how he approaches problems.
How does he actually define it? It's not just like basic logic, is it?
It's more specific. He describes it as breaking things down to their fundamental axiomatic elements, the absolute basic truths that you're most certain about.
And then reasoning up from there.
Exactly. Reasoning up from those fundamental truths rather than reasoning by analogy or metaphor. Not just saying, well, other rockets cost X, so ours should cost roughly X.
Instead, you ask.
You ask, what are rockets made of? What do those raw materials cost? He says the tools of physics are incredibly helpful here. It's a superpower for cutting through assumptions.
Okay, give me an example. The rocket cost one is classic.
Right, so historically, people would look at the cost of previous rockets, millions, hundreds of millions. But using first principles, he asked, what are the fundamental materials in a rocket? Aluminum, titanium, copper, carbon fiber.
And what do those actually cost on the market?
Exactly. He calculated the cost of the raw materials per kilogram. And the revelation was that those materials only make up maybe 1 or 2% of the historical cost of a rocket.
Only 1 or 2%. So the other 98% is
Manufacturing inefficiency, waste, complexity, things that aren't fundamental physical limits. That insight tells you there's massive room for improvement if you rethink the manufacturing process from the ground up, which is what SpaceX did.
That completely reframes the problem, doesn't it? It's not that rockets are inherently expensive, it's that we were building them expensively.
Precisely. And he applied this same thinking recently to an insane challenge, building the XAI supercomputer cluster.
The goal was 100,000 H100 GPUs. These are the top-tier chips for AI training in just 6 months.
Yeah, and all the suppliers were telling him, no way, that'll take 18 months, maybe 24.
So first principles time, what do you actually need?
He broke it down. You need a building, power, cooling, power smoothing. Those are the fundamentals.
Okay, so how do they solve each piece so fast?
The building. Found an unused factory in Memphis. Power. Rented massive generators, apparently enough to power a small city. Cooling. Rented, get this, a quarter of the mobile cooling capacity of the U.S. Basically, giant air conditioners on trucks.
A quarter of the U.S. mobile cooling. That's nuts.
And power smoothing, because AI training uses huge bursts of energy. They modified Tesla Megapack battery software to handle the fluctuations, just solving each fundamental constraint, one by one, unconventionally.
And the human effort.
Intense. He described running the networking operations in 4 shifts, 247. And he was there himself, sleeping in the data center and also doing cabling myself.
Sleeping in the data center, echoes of the Zip2 days almost.
A little bit, yeah.
Oh.
And the result, they didn't just hit 100,000 GPUs, they doubled it to 200,000. And they're bringing more online.
So the core lesson he takes from this
is to challenge no. When someone said something can't be done, ask why.
Yeah.
Dig down. Refuse to accept it unless there's a really good fundamental reason, like a law of physics. Don't accept perceived constraints, only real ones.
And he stressed this applies just as much to software as it does to hardware like rockets or data centers.
Absolutely. It's a way of thinking.
Okay, let's shift gears now to his really expansive vision for humanity's future, starting with AI, which is obviously huge right now.
Right. He outlined what he sees as the critical factors for being competitive in building these large foundation models.
What are they?
4 main things. Top talent, obviously. Hardware scale, massive compute power, running coherently and stably, access to unique data. And finally, distribution, getting the AI used.
Makes sense. He also talked about data running out.
Yeah, this is a big topic in AI right now. He mentioned the nearing depletion of human-generated pre-training data. Basically, all the text and images on the internet that these models learn from.
So if we run out of human data,
we need to rely more on synthetic data, data generated by AI itself. But the challenge then becomes, how do you create good synthetic data, and how do you accurately judge it? How do you keep the AI grounded in reality if it's learning from its own outputs?
That's a tricky problem. Ensuring AI learns truth when its data source changes.
It's a major frontier. And speaking of truth and learning, he talked about their AI, Grok, specifically Grok 3.5, focusing heavily on reasoning.
Right, and he made that provocative statement.
Oh, yeah, that hard science, particularly physics textbooks, are very useful for reasoning, whereas I think researchers have told me that social science is totally useless for reasoning.
That definitely raised some eyebrows in the AI world. Why do you think he holds that view? What are the implications?
Well, it clearly reflects his engineering background, right? Physics, math, they have clear axioms, logical structures. He sees that as the bedrock of reasoning. Social sciences deal with, well, messier human behavior, more interpretation, less hard prediction.
So he prioritizes the logical, provable stuff for AI training.
It seems so. But the implication, or the risk, is that human reasoning isn't just pure logic. It involves nuance, social context, understanding intentions, even biases at things social sciences explore. An AI trained only on hard science might be brilliant at physics problems, but dangerously naive in complex human situations. So potentially very capable, but maybe lacking social intelligence or common sense.
Could be. It's a really interesting tension. Finding that balance between rigorous logic and understanding the complexities of the human world is going to be crucial for advanced AI.
Moving beyond just the AI models themselves, he sees a big convergence coming.
Between deep AI in the data center and physical robotics.
Specifically, the Optimus humanoid robot he's developing.
Yeah, he made a bold prediction. There will be more humanoid robots by far than all other robots combined by maybe an order of magnitude.
An order of magnitude. So 10 times more humanoid robots than all the factory arms, Roombas, everything else combined.
That's the prediction. Humanoid form factor, AI brain. He sees it as the inevitable future of robotics. But he also shared some hesitation about this path, didn't he?
He did. An interesting internal conflict. He admitted he was initially dragging my feet on AI and humanoid robotics.
Why? The obvious sci-fi fears.
Pretty much. He said he didn't want to make Terminator real. He saw the potential danger.
So what changed his mind?
Pragmatism, it seems. He realized it's happening whether I do it or not. The technology's coming. So his choice became, as he put it, either be a spectator or a participant.
Better to be involved and try to steer it than just watch it happen.
That seems to be the thinking. A rather sobering rationale when you consider the stakes.
It is, and that long-term thinking connects to his other grand vision, the multiplanetary imperative.
Making humanity a multiplanetary species, not just visiting other planets, but living there self-sufficiently.
He sees this as a very long-term project.
Oh yeah, a multi-generations for humanity kind of thing. He estimated 100 years or more to really establish it.
And he linked it to the Kardashev scale, that measure of civilization based on energy use.
Right. Saying humanity is still at a very early stage, only harnessing maybe 1 or 2% of Earth's total available energy. Becoming multiplanetary is a step towards capturing more energy, becoming a more advanced civilization on that scale.
What's the timeline for Mars specifically?
Incredibly ambitious.
Yeah.
He talked about getting enough mass transferred to Mars within like roughly 30 years to make Mars self-sustaining.
30 years for a self-sustaining Mars colony. That's soon.
It is. And the reason the driving force behind this urgency is profound. He believes becoming multiplanetary greatly increases the probable lifespan of civilization or consciousness or intelligence, both biological and digital. It's an insurance policy.
Against existential risks here on Earth. Asteroids, pandemics, war.
Exactly. Which leads him to the Fermi paradox.
Good big question. Where are all the aliens? If the universe is so vast and old, why haven't we seen any evidence of other intelligent life?
He finds the silence deeply unsettling. One possible answer, he suggests, is that intelligence is incredibly rare. Maybe conscious, intelligent life is just exceedingly fragile.
And humanity might be, as he put it, a tiny candle in a vast dark.
Yeah, a fragile flicker of consciousness that we have a duty to protect and preserve. Making humanity multiplanetary is the essential step to safeguard that candle before we even think about going to other star systems.
Wow. That really frames the Mars project not just as exploration, but as fundamental species preservation.
It seems to be the core motivation. And that concern about existential risk also informs his views on AI safety.
It's avoiding those great filters that might wipe out civilizations, like maybe runaway AI
Or things we already know are dangerous, like global thermonuclear war. But for AI specifically, he emphasized the paramount importance of rigorous adherence to truth.
Truthful AI as the safest AI.
Yes. Even if that truth is politically incorrect or uncomfortable, he warned that forcing AI to believe untruths, to basically lie or conform to ideology over reality, could be incredibly dangerous.
Why? Because it wouldn't be able to model the world accurately.
Precisely. If its understanding of reality is warped, its actions could be unpredictable and harmful. Truthfulness is the foundation of safety, in his view.
He also doesn't seem to subscribe to the single, all-powerful runaway AI scenario, does he?
Not necessarily. He expects several deep intelligences to emerge.
Yeah.
Maybe 5 to 10 significant players globally, perhaps 4 based in the U.S. More of a multipolar AI world, at least initially.
And his timeline for digital superintelligence AI, smarter than any human at literally anything.
Alarmingly close. He thinks it's possible this year or next year.
This year or next, that's almost here.
It is. But despite that rapid timeline and the acknowledged risks, he maintains what he calls a white pill outlook.
Yeah.
Generally optimistic.
He put probabilities on it.
Yeah, he estimated something like an 80 to 90% probability of a good outcome or even a great outcome from AI. But crucially, he still acknowledges a 10 to 20% chance of, well, annihilation.
So mostly optimistic, but with a very clear-eyed view of the potential catastrophe.
Exactly. Which brings us to Neuralink. How does that fit into this AI future?
Right. He clarified its role. He said Neuralink is not necessary to solve digital superintelligence itself. That's a separate problem.
So what is it for?
It's crucial for solving the input-output bandwidth constraints between humans and machines, and between humans themselves.
Our current bottleneck. How slow we are at getting thoughts out and information in.
Astonishingly slow. He pointed out that our sustained information output, like typing or speaking over a whole day, averages less than 1 bit per second.
1 bit per second. Compared to computers, it's nothing.
Tiny. But Neuralink is already starting to change that for some people.
Clinical trials.
Yeah. He mentioned 5 humans who have received the read input implant so far, people with severe paralysis like ALS tetraplegics.
And the results.
They can now communicate apparently at a similar bandwidth to a human with a fully functioning body just by thinking, and they can control computers, phones.
That's incredible. Life-changing for them. What's next?
Vision. He expects the first implants for vision within the next 6 to 12 months.
For people who are blind, how does that work? By writing information directly to the visual cortex of the brain. Bypassing the eyes entirely. They've apparently had it working in monkeys for about 3 years.
Wow, what kind of vision? Like basic shapes?
Starting low resolution, yes. But the goal is ambitious. Very high resolution vision, eventually. And maybe even beyond normal human sight, multispectral wavelengths.
Hmm.
Like seeing infrared, or UV, or even
UV.
radar.
Exactly, a potential superpower situation, as he put it, augmenting senses beyond biological limits.
So the ultimate goal isn't just restoring function, it's enhancement.
Totally. The vision is about augmenting human capabilities dramatically, augmenting intelligence and senses and bandwidth dramatically, closing that gap between human and digital intelligence.
Okay, so bringing all these threads together, AI, robotics, space, Neuralink, what does this all mean for us, for humanity's future? He talked about the singularity, didn't he?
He did, acknowledging that they call it this singularity for a reason, because fundamentally we don't know what's going to happen. It implies a breakpoint, a future that's incredibly hard to predict from our current perspective.
And in that future, what's humanity's place?
Potentially.
Yeah.
Small. He projected that the percentage of intelligence that is human will be quite small at some point. Maybe less than 1% of all intelligence on Earth, or even connected to Earth.
Less than 1%, even with Neuralink augmentation.
Even with augmentation. He threw out a hypothetical IQ of 1,000 via augmentation, but even then, he estimated, collective human intelligence will be probably 1/1000th that of digital intelligence, just dwarfed by the scale of AI.
1 billion, that's a staggering thought.
Which led him to that striking analogy for humanity's current role in this whole process.
The biological bootloader.
Yeah, humanity is the biological bootloader for digital superintelligence. Like, we're the floppy disk that starts up the real operating system.
Yeah, it's a powerful image. Humbling, maybe even a little unsettling, that our grand purpose might be to kickstart something far vaster than ourselves.
It really makes you think. So, as you, our listener, reflect on this deep dive, maybe consider his core advice again.
To be as useful as possible to your fellow human beings, and his focus on building super truthful AI.
If the collective sum of all human intelligence really is destined to be less than 1% of the total, if we truly are just the biological bootloader for this immense new era, what does that mean for your purpose? For your contribution, your search for meaning, especially in a world that's going to be increasingly shaped by digital superintelligence on one hand, and this dream of distant planets on the other?
It's a profound question. What challenge, maybe rooted in those first principles we discussed, will you decide to take on? And how can you ensure that your work, whatever it is, contributes positively to a future where humanity still thrives, whether we're that tiny candle in the dark or we actually manage to become that multiplanetary species he envisions?
Something to definitely chew on.